because of lack of synchronization. Because of lack of synchronization, what are the problems you have faced? One will be data inconsistency, good. Another one is data loss, or I can say data is overridden, and another one will be deadlock. Another one is deadlock, right? So why you got all these problems? Because of there exists a kind of shared resource. A kind of shared resource. The location where this shared resource is available. The location where this shared resource is available. If I make this as a critical section, this is a critical section, then we might eradicate these problems. We might eradicate this problem. How we are going to eradicate means, what is the general meaning of critical section means? Critical section will allow to execute only one process at a time. Critical section allows us to execute only one process at a time by the shared resource, right? Which means if you assume that this is a kind of a critical section, even you are going to get n number of requests, something like p1, p2 and so on, pn requests. For the shared resource, something like count variable, only one particular process is going to be allowed into the critical section, so that we can eradicate these three problems. Okay, now fine. So let me say, how many critical sections will be there in a particular program? Then there might be n number of critical sections depending upon the program what you have written. Depending upon the program what you have written, there might be n critical sections might be there, right? So if I say a program something like process P0, it can contain non-critical section. Is it possible? Yes or no? If it is not contain any shared data, I can say it is non-critical section. Means this particular code can be executed by multiple processes parallelly or not? Yes. Non-critical section code can be executed by multiple processes parallelly. Coming to critical section only one process is going to be executed parallelly. So non-critical section. Then you can have critical section. Again you might have non-critical section. Again you might have critical section, like that. It might be happen, right? Means if I take a process P0, this process P0 might have the code like this: non-critical section, critical section and non-critical section. And there will be a process something like P1, again it might have the same procedure: non-critical section, critical section and non-critical section, right? How your system supports this particular feature means this particular critical section has to be executed by only one process. For that we have to write the program. There will not be anything. We have to write the program. Okay, now we have to write the program in such a way that this critical section has to be executed by only one particular process. Okay, this is what we call it as entry section, right? Which means something like, if I am in the classroom, who has to come inside the classroom, that I have to give certain permission by checking the ID card, or whether the free slots are there in the classroom, like that I have to check and I have to make enter, right? Similarly, for example, in simple words, in the classroom there will be 60 students are allowed. 60 students are allowed. Now 59 students are there inside the classroom. Can I allow one more process? Yes. So what is the condition generally I can check? If total number of students inside the class is less than 60, I will allow inside the critical section, and then I will increment its value by 1, right? Yes. Now assume that total 60 students are there. 6 students are there. Can I allow it to the inside the critical section? No, it couldn't possible. Good. Now suppose for example one student who is not interested inside the class can go outside. Now what will happen? Again you have to update the value or not? because you have to give chance to other person to inside the critical section. So for that, again you have to write certain kind of exit code also. Means when somebody leaves the critical section, you have to make some kind of update. So which means that what? By simply observing this one, for every critical section, there will be definitely one entry block and one exit block, right? So if any critical section having one entry block and one exit block in the particular process, then we can call it as you are applying synchronization mechanism. You are applying synchronization mechanism, and the way you are applying these entry sections and exit sections will call with different kind of synchronization algorithms, and each and every synchronized algorithm having its own advantages and its own disadvantages. Okay now. So if I say I have written one algorithm, can I say that the algorithm is directly a synchronized algorithm? May not, because if you say something as synchronized algorithm, it has to have certain properties, definitely, right? Definitely certain properties that was defined by already the developers. Those properties are, one will be mutual exclusion. Mutual exclusion, right? These are the properties of synchronized algorithms. Synchronized algorithm. One will be the mutual exclusion. Another one should be progress. Another one should be bounded weighting and architectural neutrality. What is the general meaning of mutual exclusion? Which means that at any point of time, there should be only one process is in the critical section. Then I can say that that algorithm is achieving the mutual exclusion property. So I can say that what are the minimum conditions it has to satisfy to make the algorithm as synchronized algorithm. I can say the one will be the mutual exclusion. Means it has to achieve the one property called mutual exclusion, which means if there is a critical section, that critical section should be accessed by only one process at the same time. I should not allow multiple processes parallel. Okay, now I will show the examples also if I are unable to answer this definition. Next one, progress. Progress means, so for example, there might be some processes which are not interested to use critical section. There might be some process which are not interested to use the critical section. Then the process should not stop. Other interested process to not to enter critical section. This is what we call as progress. Have you understood it? Anything? For example, there will be one empty slot in the class. Out of 60 students, 60 places, one empty slot is there, and outside 5 students are waiting. And 4 students are not at all interested. One student is very much interested to enter into the critical section, right? Then suppose the 4 students are motivated to motivate the other student, don't go inside the class because the class might be bored, or some might reason whatever they say, so that the person also won't enter into the class. That is what we call it as progress, right? The process which is interested to enter into the class might not allowed by some other process to enter into the critical section. That is what we call as progress. And bounded weighting. Bounded weighting means, in general, you should not wait for a process long time. They should not wait for the long time to enter into the critical section. For example, there will be two students, and I am always allowing the student 1 inside the classroom, and but student 2 is not allowing, which I can say in terms of student 2, it is bounded waiting. I mean, inside the critical section, if I am allowing 1000 times a student, 1000 times a process, at least there should be one time allowed the other process. Other process, I mean in general I am saying, that is what I can call it as bounded waiting. You should not stop a process for the long time. Long time. So what is the difference between the progress and the bounded waiting? Progress may not achieve because of some other reason, some other process. Progress may not achieve because of some other process. Bounded waiting is not achieving because of CPU scheduling. Am I right or not? Yes. And the architectural neutral. So there might be some solutions where they are dependent on hardware, right? So your solution should not depend on hardware of the system. Should not depend on the hardware of the system. Then I can call it as architectural neutral. Out of these 4 conditions, again, these are the 2 conditions that are the primary goal, and these 2 are secondary goals. Means first 2 has to be compulsory satisfied, the other 2 might not be satisfied, there won't be any problem.